Tonight, in Rubber Duck Engineering, our intrepid heroes will add tracing to our garbage collector, or at least we're going to try.
We're going to do it. I have a good feeling about it.
You have a good feeling? Well, we started writing down all the things we had to do before we get to tracing, and I was a little overwhelmed by the list.
There were a few steps between where we are, but at the end of the last episode, we were fighting the Rust compiler, and we won in overtime. And we do have
it was like double overtime.
It was sort of a double overtime, but we got to the point where we could actually collect some garbage, so that was pretty legit.
Mm-hmm. I actually briefly played with the code this weekend to try and like make numbers size variable and like actually, but then I threw it all away because I decided that was the show and we should do the show.
So you practiced a little bit. Excellent.
I did. I wanted to play with our little garbage collector. So at least I have some idea what's going on. And I feel much more awake, which is always good tonight. So that helps. Oh my goodness, it's maybe Hal 9000.
Thanks for joining us.
Okay, with that intro, shall we get to the code machine? We have a lot of code to write.
Yes. So context, if you didn't see the previous episode, we were working on a compacting garbage collector, which once it's working, we plan to plug in to the Wren virtual machine that we've been working on for a number of episodes. Oh, wow, everyone. There are tons of people saying hello.
Oh, my goodness. So many peoples.
Welcome.
So many peoples. Let's see.
Hi, welcome. Hey, welcome.
It is a party tonight. So yes, we took some very brief notes about what we had to do to actually get to tracing. So tracing is the idea that we, from a single root, can actually find all the various objects. So we know which ones not to delete. But it looks like we have a few things to do to get there.
Yes, we are writing this garbage collector in Rust. A lot of unsafe Rust, which is a little bit scary, but Rust nonetheless.
Well, I think there's probably even a show, or at least a pass to make over the code to make more of it safe when we better figure out what we're doing.
This is true. Should we show the collect function? So the collect function is the main thing that we added after we got the Rust compiler to accept the code.
Yeah, I'm trying to remember what all we did. I guess it's in the Git history because they were separate commits.
Yeah, but this is the key of it. So the key is basically you iterate over the cells. So the cells are the things that the handles are pointing into. So they're like the roots of the GC. Mm-hmm. And then for each object you encounter, you allocate some space in the new space for it, and then you copy it over, and then you update the pointer in the cell to point to the new space. So all of the handles now refer to the new location. Then you swap the new and the old space, and you get rid of the what used to be the old space.
Makes sense. So, and with this, our little test case that we showed last time, that we wrote last time, this now passes. We're now.
Do you want to run it? Should we prove it to the viewers that it actually passes?
I got to find a terminal here. There must be like a way. This is the way to like get the terminal and not make yet another new one. So if I do, was it Rust? No, it's cargo test, I think.
Boom, passed. It's legit.
So we make a heap. We assert that there are no used objects. We make two objects that happen to be number objects, and this is all kind of fake because the number doesn't even have anything in it. We let go of this handle with Rust, and then we assert that we are using two objects still. Then we collect, which is what we just looked through, and then we are now only using one object. Make sense?
Yeah, so I think if you go look at the collect function, you can see the first problem that we're going to need to address, which is here on line 113, we just sort of assume that the thing that we found is a number, and therefore we assume the size that it is.
Okay.
So in the previous episode, we went in a little bit of a circle talking about needing like an object header of some sort. Mm-hmm. And I think this is a good signal that we probably need that now.
Yeah, you definitely don't want this in your generic, like this could be in a totally separate file. It doesn't even know that number exists, right? Mm-hmm. In our generic heap here. Okay, so how are we going to solve this?
I think we should introduce a very basic object header and then go from there.
Okay. And is an object header just an enum, or like what are we?
Well, clearly, like a thing that we need in the object header is the size of the object.
Okay.
So maybe we just start with a struct that contains the size.
I'm trying to use this new follow feature that you taught me about.
Whoa.
Whoa. Okay. It's like I see through your eyes. It's amazing.
Should I try this?
Yeah.
So here we have number. So maybe traceable.
Okay.
We're going to want to like compress this down to smaller, like use fewer bits. But we can start here.
Okay.
And I have no idea if this is like important or not. But I really want to write repr C here.
Whoa. Sure. I remember having to use this in doing the C API. I just changed the way that the struct gets laid out. But why do you care?
I don't know if I care. Put it that way. But I want to be able to basically mem copy this thing in and out of the heap.
I see.
So let's go.
Why does this need to get mem copied? Like, why isn't it just like why isn't this part of like number, like some trait that number implements that says like, give me your header, and then number can store it wherever the heck it wants?
Yeah.
Would that be more rusty?
I think that what's happening is we don't want to mix the like Rust object models and the heap object models. And so like, as you see, our number class doesn't really do anything. It's like a marker that has traits hanging off of it.
Well, I mean, it's going to soon do something, right?
Yeah, so we can try to solve that problem, but I think like eventually this global handle is going to have to take a type parameter. That's going to be like, this is a handle to a number. But I think we should just stick with the object header, like solve the problems as we encounter them. Like we could write a test case where we try to like allocate two numbers and add them. But that would be a different direction from the
Correct. That was the direction I was playing with this weekend. And we don't have to go that way tonight.
So let's try this alloc. So let's try to use the object header now in allocation. So here, when we allocate, we know the size. And so I think we need to make an object header. Like, so it's going to be like size plus size of vector.
Oh, okay.
Then we're going to allocate that size. And then this pointer we're going to want to make into an I don't know quite what the right syntax is.
Okay.
And then we can say header.size equals size. And then we can alloc the thing we put in the handle is the actual object.
So remind me, why is it that we want? Maybe you just said this, and I was fighting with my computer. It was taking off like a jet plane. Why is it that we want the object header? This is because you don't want to mix the Rust object model and the heaps object model. Why you're trying to like move it out to the side weirdly. That's the part that I'm still not getting over.
So tell me about the alternative. So let's try the alternative. So the alternative would be here instruct number. Let's give this a repr C, just for the sake of our sanity's sake.
Yeah.
So then you want to say like header this thing value u64.
Sure. I wasn't trying to claim where the header needs to be. I was more expecting something like whether traceable or not. Oh, I need to turn off following you. Did I just kick you?
Yeah, you just kicked me out. That's
Oh,
fine.
God.
That's okay.
Okay. Anyways, I'll fix that in a second. I was instead thinking that maybe like this would be FN header. And then this thing for number would, do self.header.
That's fine. But I think if we do this, I'm not sure why it's mad here.
Let's see.
The trait debug. That's fine.
Non-primitive cast. Well, that's fine.
But I think if we do this, then we can say this is the memory layout we want in our heap. We first have an object header, and then we have a value.
Mm-hmm. Oh, yeah. I'm not saying that your approach is wrong. I'm just trying to understand it.
Because then we don't need this. Like, we don't need any of this. Well, I guess we do need this. We could say, like,
why do we need to be able to access the header this way?
Let's try this, right? So,
like, what you're proposing here in this like object layout in your heap is equivalent to having like a side vector of the headers, right? That like maps from the pointer to the header.
That's true. So why do you put the header inline in the heap? Is that your question?
Yeah, I mean, like, I totally understand like why when you're writing this in C++ you do that, because you just do pointer math all day in C++. But Rust really tries to fight us about the pointer math. Which I'm not saying we shouldn't do it. It's just, like, again, in C++, it's very normal, or at least I remember in JavaScript core and stuff like that. You just take the pointer you're given, or in C++, right? You take the pointer you're given and you like back up to see the v table from the pointer. That's basically what we're doing here.
So what does William say? If you're walking the heap, you don't know the type, so you don't know what impl to use. Yeah, so that's part of it. So we're going to have to put that in our object header. And I think it boils down to the fact that the objects are variable sized. And so like you don't know how many object headers you want for your heap. It's like when you're making a file system and you don't know how many inodes to make, right? And so here, if you just store the headers inline in the heap, then you know that you always have enough, the right ratio of like headers to payload. Like when we do strings, which I want to try to do this episode too, like the payload will be much, much larger.
All right. Well, I'm going to stop. Let's keep going. I'm slowing us down here.
Yeah, this is just sort of the traditional way. Like maybe there's a better way that we can think about doing it. But I think now that we've done it this way, I can say that
because like in C++, you would literally do self, -8 or whatever, minus size of pointer.
Yeah, but we won't have to do that here. So now we can say this is a mutable t. Like we've gone and put an entire t in our thing. And then we can say object dot header, because traceable promises that we can get the header. Now record the size.
Okay.
We don't have to do any of this pointer math. This is mad here.
Which is mad? The 128?
Yeah.
Number size we must have removed. This is mem size up if we want that instead.
Oh no, here on line 128. So I need to figure out how to convert pointer to reference.
Oh, I had to do this in the C API for ran Rust.
Okay, so first of all, we need to be unsafe.
Got it already.
And then apparently what we're supposed to do is it's like a two-stage cast. Say first as star t, and then you take the r.
Oh, I thought there was a function to do this.
Oh, there may be. This is just what some random Stack Overflow article recommends.
Yeah, I can look up what I landed on. William says card tables are similar to what you describe and work well for a single bit, but get unwieldy to represent bigger things.
What is a card table?
I don't know. I'm not entirely sure what William is referencing. I don't know which part of the conversation that was.
So I think allocate is happy now. So now we can go back to collect and figure this out. So we can say, like, the rule of objects, when we have a pointer to them, we have to be able to recover the object header.
This is how. Standard mem transmute from, I don't know if this is any better than what you did, but this is how I did it.
Okay.
Anyways, you were saying, sorry.
So we need to be able to do something like this. We need to say let header equals this as star mutt object header.
Okay.
The rule of objects is they have to begin with the header.
Okay.
Yeah, transmute is super scary. Transmute is just like pull off all the safeties, be like, pretend like this thing is this other thing, and any number of horrible things can happen when you do that.
The pass that I haven't made on the C API in that portion of code that I was that code had sort of gone through the like, let's just get it working. It needed another pass to clean it up and figure out what was safe and what was unsafe and what needed to be a macro and stuff like that. But anyways, back to this. I was actually talking about this.
This worked here. We Oh, sorry. Go ahead.
No, go ahead. I was going to tell a story.
We managed to get rid of our hard-coded number from here.
Okay.
So we could recover the size from the header. And then, should we try running our test? I think we have a couple more errors to work through.
We have errors. Cannot borrow object is mutable. Why is it mutable? Okay. It's behind an at reference. Well, this is going to have to be. Is it mute at or at mut?
Oh, yeah, that makes sense.
No function associated with size. Yeah, so this is now.
Yeah, this is now just regular etcd size.
Is that true?
Yeah, now we're storing actual legit number objects in the heap. Our number object now includes the header.
Oh, I see. So you ended up with some sort of hybrid between what we were discussing?
We did what you suggested. Like we laid out a struct for the number that included the header.
Mm-hmm.
Like there's another way of doing this where basically you don't write this here. You just write this, and then you know that just before the number in the heap is the header. But we can also just do it this way.
Well, I worry that we may have ended up in the sort of the worst of both worlds. In the previous method where there's a trait, the author doesn't need to know, there's this magical thing where I have to do repr C and lay it out with the first thing. And in your proposed originally where you don't have it in, the author also doesn't need to know that. But now we're in this world where like the author needs to both repr C and know to put the header first, or they're in a really bad time.
That's a good point. Like we aren't using the trait for anything yet. So maybe like we can delete the trait. Should we delete the trait? We can add it back if we need it.
Well, I think just our compromise ended up being worse than either extreme.
Yeah, so let's get rid of the trait. So we don't need this trait at all.
Mm-hmm. And then I think we store it without. We store it before the object.
But you want to store it before the object?
Well, do you hear what I'm saying? That I'm right now. We've put this undocumented, unenforceable by code constraint on someone adding a new object to this thing that they have to put a header first in the struct layout. Whereas if we had a pure trait approach, we would not have that constraint.
Mhm.
And if we had to store the header before the object magically, we would not have that constraint.
Mhm.
But in the second one of those, where we magically store it, the size adjustment needs to be done somewhere.
So you want to delete this field here?
I think, yeah, like if we're gonna,
Okay, let's do it.
yeah,
Let's delete that field.
Let's go back to your original idea. I think that has less mental overhead on the consumer of this API.
Okay, so then the size we want to allocate is this std, and then size of. There are a couple of comments in the chat. You may want to.
Oh, I see. Sorry, let's see. The comment from card tables are a GC thing. They're introduced to avoid writing when marking, but they associate information with every location on the heap. All right, so they're like a side vector from heap pointers to extra stuff, which we were sort of talking about in the pre-show about maybe needing something like that to do finalizers. And Gotbill says, nice.
Okay, so then the header pointer is cell.pointer minus equals.
I think that Rust doesn't have minus equals on pointers, but yeah.
What's minus or sub or something?
Yeah, it's like difference or sub or something like that. We'll see.
So then get me back my header pointer. Then I want to allocate the size. I really just want this thing to be a constant. Like I use this so much.
Sure.
I mean, this is more like what you would do in C.
Mm-hmm. Well, again, my earlier point was just that we ended up in this compromised space that I think got neither advantage of either side.
You can check. I think that's correct.
But yeah, this feels very familiar, like what you would do in C++.
We can make little functions that are like header from dr. Wait.
When in C++, you would just put that on your abstract base class that knew how to like subtract from its own pointer.
Mm-hmm. This is
I guess you could do that here too.
Header minus object size. We can add these helpers later, but do we have errors expecting a semicolon?
I think I'm safe. Not quite around the right things. Expected semicolon. Too many? Not add use size to mut.
Oh, we need to add or whatever. They have these funny.
It just didn't do operator overloading for the.
Yeah, I think they want you to realize that you're not what you're doing.
And then wrap it in unsafe. Yeah, anytime we call that, we got to do unsafe. Like, this whole function needs to be unsafe, basically.
Right, so maybe we should write these.
Well, I'm following you, and I need to stop.
Header.
Stop keying you.
I'm not sure exactly what the type is supposed to be.
Whoa, I'm still following you.
All right, I'll stop typing. Good.
No. That's
Take it over.
Not your error here. I need to figure out how to use my technology here. Ah.
Do we just need more of SP and unsafes?
Unsafe is correct.
Yeah, we should extract these unsafe things into functions.
Okay, which you were working on.
But let's just go through it and run the test, and then we can do the refactor once we have the test working.
That was getting to the part of the like story time earlier. Maybe I should wait until we're running tests. Oh, no problems. Oh, failed.
I think the sizes are wrong now.
Because they do not include headers.
Yeah, we just need to say
like a size of helper. Yeah, okay, bit hacky, but yeah.
We can clean it up, but I just want to get it to pass.
Failed. Rust backtrace. What are we doing here? Panicked. An assertion failed. Left 24, right 16. Left 24. We're using 24, and we only have 16.
But the first one passed. That's interesting. What did we do wrong? Oh. When we stored the size, we already added in the header. I think we should just store the object size.
Okay.
We always know what the size of the header is.
Okay. Do we need to rename this to the object size or size of t or something?
Rename this to object size. Okay.
Okay, let's try our test. Yay!
Yay! Okay. Oh, Giphy. Hi, Giphy. Welcome.
Hi, Giphy. Yeah.
Okay, so do you want to refactor these save functions? Or like...
Sure. Okay. How do I turn you off?
Oh.
You're unfollow participant. Okay, there we go. Oh, I see.
It's whether unfollow is better than kick me out.
Yeah. Well, it was an X. I figured maybe the X would do something. Although I'm glad that it didn't ban you.
Oh, that would be a really powerful X.
Okay, so what are we looking at here? Yeah, so we need to. So there's a question of can we just put these on? Can we put these on the trait?
We don't have a trait. The trait is gone now. We could put them on object header. We could put them on object header, right? Object header could have a bunch of functions like, here's my pointer, give me the object header. Here's my pointer, give me the object.
Oh, I see. Like a static.
Yeah. It's like object from or header from pointer, right?
Yeah, exactly. All right, so where is object header here? Impl. You wait. Okay, like that. Thank you. And this is going to be this one. Well, this is not going to do it. That's not the one.
Right. So we're going to have to distinguish between object pointer.
This is header pointer.
This is going to be like from header pointer, ptr, sub.
We're going to end up with our own pointer types for this sort of thing?
Oh, yeah, maybe there's a way of doing this with pointer types that would make it prettier.
Well, it's just that's the rusty way. Like I found myself doing that in the rest of Ren, where all these things were U-size, and then I was changing all the U-size to have specific types.
Okay, maybe it's a good idea, but we can do that in a separate refactor.
Yeah.
And then if we had an object header, object
from header pointer, mute header pointer.
Self.
Okay.
Let's add this.
This goes here. Goes here. I'm just your little cleanup crew. It'll depend on me to type any code, but I'll fix it.
Let's mutt t star.
I can get object pointer.
That's right. Saying that the object comes right after the header. And you want to do the same kind of dance here. Header pointer as t. Reborrow it. Be unsafe. What I like about Rust is because it makes you put these unsafe markers in your code, then you have an idea of what you want to encapsulate. Oh, that's a good idea.
This isn't quite the full-on because these are just aliasing, but you can do more where then they're not even possible to use them with each other.
Yeah, this is good.
This is the light version. There's a slightly heavier version.
You can pick up to that heavier version.
Yeah. I was first introduced to this concept in WebKit when I was a much younger lad for differentiating between 0 index and 1 index integers.
Oh man, for like the errors in the web inspector, like what line of code?
There were just parts of WebKit that had to be 1 indexed.
Yeah, we should have totally applied the new type pattern, but we're going slow. We're taking it easy on ourselves here for a little bit.
What's the new type pattern?
That's making the types actually stronger.
Yeah. Yes, correct. I just don't know how to quickly type that. I can go find, and so.
Well, theoretically, once we put all these in the right place, we should be able to just switch it over to be strong types.
Yes.
So
but it's slightly, when you make them a new type that you then have to like inherit certain things, like you have to inherit the ability to add them and things like that, or you have to define the ability to add them.
I don't know.
At least the anyways, let's keep going where we are. Expected raw pointer.
So let's try this. So we want the header. So now we should be able to say object header from object header.
And does that say that cell.pointer? Oh, I see. This is always object pointer. Okay.
Oh yeah, I changed it. And then header.
Expected raw pointer from heap cell.
So now object header, we can ask it for the allocation size, right?
Oh, this expects to be mutt. Is it supposed to be in the heap cell? Like this may have to be mutt object pointer and
I'm not sure.
Missing lifetime specifier.
Missing a lifetime specifier, right?
Because it can't infer it from the header pointer.
Right. All right. A new one.
And don't you have to also put it here or something? Or you have to put it in here or something like that?
No, don't put it there.
There. A new one. All right. So this is a mutt problem because we come in as const. So the question is, should object pointer be mutt or not? What happens if we remove it? Can it specify it's mutt elsewhere? Oh, I see. So this has to be. We'd have to have mutt object pointer and object pointer. We may have gotten ourselves in trouble here, man.
We may have gotten ourselves in trouble. Should we back out and not do this?
Let's go just a little deeper for a second. What happens if we do mutt? Object mutt pointer? Which would it be? It's terrible. Someone has written more Rust than I. This one is the most concerning, this lifetime thing, because I'm not sure how to solve it. Consider reducing a lifetime here. Yeah, we don't have a lifetime to name.
I think we should back out. I think this like trying to make fancy types thing is not.
Okay, how do we do that?
Undo a lot.
Undo a lot. Well, let me copy this to a buffer.
Okay.
Hi. I undoing or are you?
I'll do it. How about that?
Okay. We've had this problem before where like, do we have separate undo buffers?
I'm not sure. You know what we should have done?
What?
As soon as the test passed, we should have made a commit.
Yes, we should have.
What am I doing now?
I don't know.
We're still an object header.
I mean, we can also do some search replace, but you're right. No, you're right. This needs to be. Oh man.
This is like this is exactly the thing that source control is supposed to save you from.
Save you from yourself. If
Well, like
you
you shouldn't have to rely on this like infinite undo buffer in your editor in order to not get in trouble.
Well, I love that we have. Do you remember when editors
Yes.
like only undid like five things? That was all you got? William says, if you did use a list of offset size type, it might be fun to just be different.
Oh, that's true. Although we're trying to keep it simple.
I don't think we've shown this one yet tonight.
Yes, we have no idea what you're doing. Okay, this is when we're starting typing this straight. So my theory is if I just delete this, that's still
My
fast.
life gets better.
Try running
Okay.
the test.
With fast tests.
Okay.
Okay,
We do have a bug though. Yeah, you should commit. Like we learned, this is an important state that we should be able to return to whenever we want to.
okay.
We have a legit bug on line 121.
No, there are no bugs.
Yeah.
121. I'm following you. Okay.
Because we want to we need to copy the whole thing starting at the header.
Oh. Yeah, this is the difficulty of having two.
Like if this is the thing that all that type stuff would help us with.
I see.
I think that fixes the bug. Does the test still pass?
Well, if it fixes the bug and the test never changed, we're missing a test.
Well, should we write the test? So I think if we wrote the test where we tried to add two numbers, that would
We're going to get to the end of the episode and there will be exactly zero tracing.
oh no.
Okay,
but we did the first thing.
No, we have one object, but yes.
Well, we made it possible to have different size objects. It's possible now. So now we can make a second object type.
Okay.
Do we want to try a string?
Let's accept that this bug will get tested eventually. Because it will.
Let's write it to do for the test.
Like this specific bug, like whenever we write anything more complicated of a test, we will catch the fact that we were only copying half the object.
Okay.
Okay. So if we go back.
It's not a bug. That's right. You can't add numbers. It destroys your numbers. That's a really good feature.
All right. All right. Let's make a second object type.
Mm-hmm. Should we do string?
Well, we need to make like a host object. That was the whole thing. And whether that's a string, that's fine.
Okay, let's make a host object.
Okay, I'm coming back to following you here. Where'd you go?
So a host object is going to have in it.
That's like host object T, really.
Yeah.
If you're making just a generic host object.
T.
And just
Public key
have
is going
value
to
t.
have star mutt.
Oh,
Right, it's going to point out to a host object. So what is a host object? So like number is a heap object. It lives in the heap. So host object is an object that lives outside of the heap, but is owned by the heap.
another way to think about this maybe is like a finalized object. Maybe that's not the right.
I mean, it's traditionally called a host object, but we can call it.
Okay. No, that's fine.
Else if you want.
I'm happy to follow tradition because again, I've never written one of these. So why do we just have a pointer as opposed to actual t here?
Because the actual memory for the host object is going to be stored outside the heap. So like, here's an example. So like, let's write like how do you get one of these things?
This is really value pointer then.
I forget where I put the thing here, but I'm not sure what to call this function.
Wait, you need to pass it a t that you then.
Well, presumably I'm going to pass it a box t.
A box t, sure, that's fine.
And what I'm going to get back out is a global handle to t.
Yep. That all
And
makes
somehow
sense.
the heap is involved. Maybe this is a function on the heap.
Yeah, it's like wrap. But then there's a question of like
it takes ownership of it, like it's like it transfers ownership, like
yeah, so like host object from raw, and you pass it the allocator, which is the heap, or something like that. That's kind of the rusty pattern, right? I don't know how often you pass around allocators and things in Rust, but
something like this, right?
why is this sad? I can't find T in the scope.
Oh, so the global handles don't really have types yet, so eventually we'll have to give them types. So the key is we're going to take this value into raw.
Mm-hmm.
We're going to maybe before we do that, we'll handle is going to be.
Does it need to be a pinned box? I think it might.
Oh, I don't. Sure. I don't.
I think Rust can move around a box T.
Well, we're going to destroy the box. This is going to like the box is going to go away.
Oh yeah.
And we're going to get the raw pointer.
Some leaked pointer.
Yeah. So somehow we need to allocate a host object. Right. We get this thing. This can fail.
Mm-hmm.
This can fail in the same way. And then somehow we're going to have to store value pointer in handle. And then somehow we need to register handle for finalization.
So you're saying we need to this is getting back to the adding numbers problem of like, how do we get to the thing inside the handle?
Yeah, so I think we're getting to the point where global handle needs to start taking a type parameter.
Yeah.
Needs to have a T.
Mm-hmm.
So should we add that?
Sure.
Okay, global handle T. Okay. T. Global handle.
Mm-hmm.
So we're gonna need like fn get, which takes a self and gives you back a T. Right, and we're gonna need fn mutt, which takes mutt self.
Okay.
Back a mutt T. Okay.
Okay. I can see that.
Okay. So then we need to go get the pointer out of here.
Mm-hmm.
We did that. We take like self dot inner at index. This is our cell. And now we have the unsafe part. Our cell HR has star const.
We have a lifetimes problem here.
And then same thing, but with months.
What is the lifetime of the returned reference?
It's going to have to match the global handle.
Is that true?
Well, it's a little bit.
Reference.
What's that?
We will never move the underlying storage that the reference is pointing to.
Yeah. So now you're getting into like safe points. Like we have to make sure that you're not. Eventually, we'll have to make sure that you're not borrowing the value during the move. But I think we should like this will eventually be a fancier type that's going to make sure that we don't actually move the object while this is happening. But for now, we'll just be a little bit unsafe. So we can write it to do that.
Yeah, it's going to have to be like a ref. Yeah, there's a Rust has some things like this.
Keep ref. Wow.
Yeah, some sort of counter or whatever that we panic if you have one of these. Yep, exactly.
I think now I'll have to go put in a bunch of T's, right? Every time we say global handle, we're going to say what type we mean.
Mm-hmm.
So let's go do that. So you get a global handle T.
Missing generics. Yep.
Alec handle. This is going to have to give you a T.
Mm-hmm. Yep.
I can give you back a T.
Yep.
So more Vespian T's. Handle T.
I wonder how much of the audience actually gets that reference.
Sorry, it's a StarCraft thing. We played a lot of StarCraft, Eric and I.
Oh, it's StarCraft 2.
StarCraft, yeah.
And this was like, I don't know, well over a decade ago. And whenever you play as any of the things, you're just constantly spamming and saying, no, you can't do that. You need more Vespian gas. In whatever voice of whatever race you were playing. Comparison operators cannot be changed. Expected semicolon. Comparison operators cannot be changed.
Oh, you need more colons. Colon.
Why does that need a...
I don't know. I can never tell when you need the colons and when you don't.
I don't know that you need to do a T there. Why is that needed? Is it inferred?
Oh, is it?
Missing generics. It's not impl T there. It's the other. I think you're. Oh, hold on. I got.
Oh, you do it. Sorry. Oh.
No, it's all fine. I just need to stop following you. This goes here, I think, doesn't it?
Okay. I don't actually know how to write Rust. Oh, we need the phantom. The phantom.
The phantom? What? You have such a funny understanding of Rust.
I don't know anything. I just...
You're like, I write in so many languages every day for so many different projects.
Who can keep track?
What is phantom here?
Phantom is nothing. We have a hint. When we get back to the error, it'll tell us the correct thing to do.
Missing structure fields phantom. Sure. Missing field phantom.
You just add the phantom. So the phantom it doesn't use any storage in your object. It's just a way of like keeping track of your type parameters so you can remember them.
I'm sorry. So I put a phantom.
Yeah.
We need the type. It's not imported. Phantom.
We need to find the phantom data.
Doesn't use any space.
I don't think use any space. It just allows you to keep track of all your type parameters for cases like this. I don't know why I needed this, but I struggled with this compiler warning for a long time, and the answer was you need a phantom.
I love your understanding of Rust.
Well, this is my understanding of like everything in the world. For me, works this way. Like I don't really know how anything works. I don't know what to type here.
Comparison operators cannot be chained.
Our viewer told us to type this. Check VS. Are we typing this in the right place?
I think that may also be an emoji. Like, I don't know where.
Oh, I thought he was trying to hint us that.
Disappointed face? I'm not hip to the ASCII emoji here. Okay, why would I don't remember ever typing this in Rust.
Okay.
But I've also never typed the word phantom data. Comparison operators cannot be chained.
I agree. More like that. I don't know. What do you want from me?
Missing generics for struct host object.
It's host object T. I thought you could use an anonymous lifetime.
Maybe an underscore because it can be inferred, maybe? Haha, I thought you could use the anonymous lifetime.
All right. Well, we'll just fight through it. Like the nice thing is the Rust compiler gives really good warnings or errors.
All right. Method into raw in current scope must have a self parameter.
Huh?
What?
Oh, it's a it's one of these. Box into raw.
Box into raw. Okay. Value. Yeah. Okay.
It's probably unsafe too, right?
I expect it is. It hasn't said that yet though. Mismatch types. Expected global struct T.
Okay. We have a question mark.
Because the global handle to host object
T. Oh yeah. This makes sense. You don't get back a global handle to T, you get back a global handle to a host object T.
Okay.
That's legit.
Can it find T in the scope?
I think you need many more T's.
You need more T's? So they put it in the wrong spot?
Like that.
Won't use your Vespin line. Can it find value index?
I agree. Self.
I'm glad you agree with the compiler. Can it index into value?
Oh, we need to
borrow it or whatever.
Borrow.
Not borrow after inner. Oh. Wait, this is why I should. Oh no! Wait, we're fighting into undo buffers here.
What's going on? Inner dot borrow.
Yeah, borrow.
And then we can do.
Well, you don't want to hold. You don't want to hold it open for that length. Right, you're still borrowing it. In fact, you may still be borrowing it at the end here.
All right.
Right, you're gonna want to put this in there to reduce the scope of your borrow.
Oh.
Can it index value? This needs to be borrow.cells.
Oh.
Right? Okay. No field pointer on option cell. Okay. I see. We get back an option. Because we could be a weak pointer and dead.
Oh.
Do we panic? So we just unwrap?
No, we just get option. We should unwrap because if we are the handle, then we know we're not dead.
Okay.
We're the owning reference.
And so we know the cell has not been cleared.
Right.
Okay.
This all gets cleared down here when we're dropped.
Okay. Cannot move out of.
Right. This is why you're going to need like this. We're not going to move out. We just want a reference.
Maybe this is as ref unwrap.
Okay. We're eventually going to have to move the borrow to its own line.
Why?
Because the lifetime of the cell is going to be tied to the lifetime of the borrow. Yeah, temporary value drop while borrowed.
Okay, go for it.
I knew it. I rewatched the last episode, by the way, and I noticed that you were like making suggestions much earlier, and I was ignoring you. And so I've been trying in this episode not to ignore you, because it turns out most of your suggestions are correct.
Oh, well, that's kind of you.
Oh, that's legit. Yeah, exactly. This is the problem we were trying to solve. So now we should be able to say handle.getMut.value pointer equals. That was the point of this whole exercise. We can now look inside the handle.
Cannot borrow handle is mutable.
All right. Handle.
Okay. So we don't finalize them.
Right. I think we are succeeded in storing a host object in the heap, but we leak it. Like when we collect it as garbage from the heap, we don't actually go and free the host memory.
Okay.
I don't know whether we're going to be able to achieve that in the next 4 minutes of this episode. But should we sketch out maybe write to-dos for how we would do it?
Yeah, we need to put the to-dos down at least.
Yeah, so I think we need here in our inner, we need a new vec. Add vec of weak pointers, and then we create. What is a weak pointer? A weak pointer is a thing that has a callback, and then here in collect.
Rust has one.
Yeah, but this is a special heap version of it. So here we need to scan the vec. Scan the vec of weak pointers. See if any are pointing into the from space. So call their callbacks. And then here we need to register weak pointer for the host object. Host object whose callback uses box from raw to tell Rust ownership. I think if we did those things, then the host object would succeed at getting actually freed.
Is it possible for us to? I think it's possible for us to write a test, and that feels like the right use of our remaining waning minutes here.
Yeah, so let's create a food like test object with a drop trait.
Yep.
And then we'll be able to see that the drop trait isn't called properly.
So it's like, whoa, hold on, we got to stop following you. Okay, struct drop object. And this can be empty, and this is simple drop for or drop. And then
yeah, so the easy thing is if you hold a like you want like a counter. You want this thing to have like a counter, right? You want like an RC to a ref cell.
mm-hmm.
Let's see.
Sure. And then you want this to be a drop. It was trying to autocomplete it for me. Drop. And we want self dot counter borrow dot mut. What's that?
Yeah. Then we can tell whether the drop gets called.
Can't find RC in this scope.
No.
That's fine. And then we do FN.
Change it to an arc.
Pass. this is let mutt heap equals heap. Oh my goodness, my notifications are going crazy tonight. Size 1000 wrap.
You started writing Swift there for a second.
Did I? Too many languages. Okay, and then we want to do let host equals. Oh my goodness. Drop object.
So we need our counter, right? Counter equals.
Yeah, I'm just gonna make it inline, but sure, that works. You actually did an RC here. Oh, you made an arc. Okay.
So,
Mm-hmm. And then 0, right? Yep. And then counter just as is fine.
we want to clone it, right?
Oh. Okay, just call counter to clone. That works with RCs. Okay, and then
we want to take it like heap handle equals heap take object host.
Okay, and then we want standard mem drop handle.
Yep.
Heap dot collect.
All right, so we want to assert eq 0 the counter.
Mm-hmm.
Borrow, I guess. And then assert eq 1.
Yep. And that should work.
Well, it should fail.
Yeah, well, it should fail. Yeah. Binary assignment cannot be applied to mutref. I don't know what this. Counter. Okay.
I bet there's a fancier, less way of doing it. But.
Yeah, probably. Or just add, right? You just do dot add 1.
Oh, okay.
I don't know. I'm
Is that a thing?
winging it here. That seems reasonable. Why? There's a way to get the thing out of the mutref. Maybe it's. Here we are in overtime learning Rust again. Your way.
Yeah, it's not pretty, but it has the advantage of, I think.
Cannot add integer and mutref.
More stars.
Stop stars. Okay. Mismatch type. Expected box found drop object. Nope.
We need to actually put the object on the heap.
Nope. Cannot compare integer with more stars.
More stars.
Trait bound is not satisfied.
I understand. Oh, it's I. Maybe this needs to be U32.
What is the right way to get? Why is it of a ref cell in the first place?
I mean, I always just use mutex. Should we do it the mutex way?
What if we just do get? Does that solve it? Type must be known at this point. So I guess I never have used arc.
I'm really just tempted to do this the mutex way.
Okay, do it the way you know.
I'm sure there's a better way of doing this. But mutex makes sense to me. Like I know what a mutex is. Let's say lock. Oh, I guess I want parking lot. Okay, well, sorry. That was a bad idea.
Okay.
We should be able to get the number out of the ref cell, right?
All right, let's see.
That must be a pretty basic thing to do, the ref cell. Borrow, get mutt.
How to access value in ref cell properly. Borrow, partner, as ref, unwrap, borrow mutt. Okay, fine, that's a different.
We can also call get mutt, I think.
Let's see, borrow, get mutt. Yes, that's what we want.
The compiler happy?
Can't compare integer. Oh.
Borrow our integers. Do that?
Won't that like pointer compare them? Cannot borrow arc as mutable. Well, is there just a get?
Or mutts.
So
this is a really funny thing to be fighting with the compiler about.
well, it's just we don't know how to use these things. So the other thing is, remember we learned the difference between ref cell and cell last time? We could make...
you want to try RC? Is RC the thing that...
RC is the thing I use.
Okay.
I don't know that it's really any different here. It's supposed to have the same...
Where does it come from? What RC. Okay. I don't think this is going to make much of a difference.
No, I wouldn't think it would either. Because I thought that arc and... All right, so... I do know...
Should just be able to say borrow here, right?
The trait bound RC oh, I see. It's a U32 and it's trying to borrow as an I32.
Okay.
Somebody is watching this who actually knows Rust. Okay, one more stab in the dark. What if we change this to cell?
Okay.
So the problem that we had last week, right? And instead of borrowing, we like get and put.
Okay.
Why does the Rust auto implement for me? Oh, gotta stop following you. Use cell. And borrow mutt. So this is just get.
All right.
And then it's
put.
It's like set self dot counter set.
Okay. That looks like very sensible code.
Match types. What did I?
I think you just need an RC clone here.
No, I think it's this thing. We made it a ref cell.
Oh,
You're just. I believe the previous code worked fine too, but that's fine. RC current clone.
This should just be get, and this should be get. We don't need the ampersands here.
No, I think we can literally just have them be normal. Unused import cell.
You just stick it in the test imports.
Oh, I see. You put it in the test imports. Whoa.
There it is.
Import borrow. That was 4, but sure. Variable does not need to be mutable. Okay. Oh my god.
We did it, team. That was much harder than expected. And now the test should fail. Oh, we didn't mark it as a test.
I see.
Minor problem. Okay, try now.
This time with feeling. Failed.
It failed. Excellent.
How does it fail?
267 is 0 instead of 1. Perfect. Okay.
Oh my goodness.
In the next episode, we will make this test pass.
In the next episode, maybe we'll do tracing.
We can just reuse the same logo, tracing again.
Jazz hands. Well,
It's a good project. It's hard, which is fun. It's gonna take us a few episodes to get there.
Yes, I agree. Epic rubber ducking. Anyways, it was great to see you,
William.
It was great to have you here, William. Thank you for all the advice. One of you, Jacques,
we enjoy the struggle. That's why we do this.
Oh, anyways, great to see you all. We'll see you next week. Next time with more struggle. Take care.
Bye.